Thank you so much. So, who here uses Package Manager? NPM? Yarn, maybe? PNPM? Something else which I didn't mention? No. OK. So I guess if you're using package managers, a package manager, you do something like me. You run npm install, and then you go to the kitchen to get a cup of coffee. You drink your coffee, and then you come back, and hopefully it succeeded, and you've seen npm working, but you have no idea what it actually did. So, as Neil said, my name is Tali Barak. I'm from Ubik, and let me tell you a bit about the secret life of Package Manager and what they did while you were having your coffee. But in order to do that, let's do a bit of a time travel and go back. And we are at the previous millennium, around mid-90s. And JavaScript was just born. It's really new. And it's far from the language that we know today. It is something that you use in order to add a drop-down or maybe a submit button on websites. It's very early on. And then we move forward, and the millennium came. And around this time, large companies like Microsoft and Google and Mozilla at the time, they realized that the web is hot, and there's a lot of money there. And they started to actually improve their browsers, the ones that they had. And at the same time, applications got more and more sophisticated, like Gmail and Google Maps and the such of it. And browsers got and part of the browsers that were a lot stronger is actually the JavaScript engine inside that became much faster and much stronger. And in order to do that, when this JavaScript engine became stronger, this guy came, and he is the reason we are all here. This is Ryan Dahl. He came up with the idea of taking the JavaScript engine from the browser and put it in order to develop web servers. But when you're building a server application, you can no longer write all the JavaScript on one page. You need to start being more sophisticated and start building modules. You need a modular system so multiple people can start working in parallel and build your server. And the legend has it, maybe some of you know, between version 3 and version 5 of JavaScript, ES3 and ES5, there was a rejected version called ES4. And part of the proposal inside ES4 was a module system for JavaScript that was called Server.js. And Ryan Dahl took this module system and incorporated it into Node, but named it Common.js. And this is the module system that we know. We are at around 2009, 2010, and Node is becoming hot. It's easy to install. It's using a language that people already know, that is JavaScript, and people start writing lots and lots of modules. And one of the people that identified this hype was this guy. This is Isaac Schluter. And he realized something really nice. If you want to move faster, you can either push harder or you can reduce the friction. This is physics. This is Newton's law. And he decided that if everyone is doing one and pushing harder, he will do the other, and he will reduce the friction. And the way he realized you can reduce the friction is by providing a package manager that will help people to actually share their code in a much easier way. And he came up with this idea. So if you wanted to use someone else's code, it was stored as a tarball, which is sort of like a zip file somewhere in the on the internet. You should know where it is. And you could write require npm install and the URL to the tarball, and it will bring your code and download it to your machine. This is nice in the start, but eventually you cannot manage all these zip files or tarballs around the internet. So he went one step further and decided to have a registry, a central location where you will actually have all those packages, or at least point to those packages, which will tell you which modules they have. And then you can access this registry and download your package. And in order to do that, in order to find the right package, you need to have a very simple file. Initially, this was called npm.json, but later, quite soon, he renamed it to package.json, which I assume everyone here is familiar with. And he decided that only 2 fields are going to be mandatory. And what he actually did, he went to GitHub repos of people that wrote Node code and pull requested them with this file. Why can't you just share it on NPM? And the 2 fields that are mandatory and are still the only one mandatory on package.json are the name that will identify the package and the version number. Let's do a small the version number actually is using Semver. Semver is short for semantic versioning. And he decided, and that was an early on and very bold decision at the time, that he will use only Semver. Now it's quite obvious. A lot of other tools are using Semver, but it was not that obvious back in 2011. So now let's do a small detour and understand what Semver is. Semver is a means of communication. That's what the semantic comes from. Semver is built of 3 numbers. There's a 4th part, which I will not get into it now. The rightmost one is called the patch. And the patch is actually saying, I didn't do any changes in my code except for fixing bug or multiple bugs. The next one, the middle one, is called minor. And minor means I introduced new functionality in the code. By the way, introduced new functionality is a euphemism for I introduced new bugs, but that's a different story. But still, it should be backward compatible with if you used this package code, this module code, and it should work fine. And the last one is major. And the major actually says there are breaking changes. I cannot commit that your code will work the same. And we are using Semver. Most of the time, we can just specify a specific version. This is, by the way, Lodash versions. So I can specify that I want version 3.9.1. But it's more common for us as developers to use a range of versions according to the Semver semantics. So we could use this sign, the tilde, which is actually saying, give me any patch version after 3.9.1, but not a minor or not a major, just a patch. Or we could use another common one, which is the carré, which is saying, give me any minor version after the version that I specified. And there is more syntax, which I will not go into it. Remember the thing about versioning. This is Chekhov's pistol, and it is here on the first act. It will fire later on. So let's go back. What is NPM at this time? We have the registry. Okay, this is where we store our packages. We have the search website. This is a new one. There were older versions. This is where you can look for modules that you might want to use. So you can just search according to a name or maybe some keywords that were identified. And the last part is you have a CLI, which is on your local machine. And you use it in order to grab those packages, also to publish, but we will talk about getting them. And NPM actually became more and more popular. So it was, again, around 2011, in quite early version, it was bundled together with Node. So until then, you had to install NPM separately, no longer. When you install Node, you get NPM. And I guess most of you already know that. And the love child of this synergy between Node and NPM is the Node modules folder. And what does it do? So this is my project. And I want to use the foo package in it, somewhere in my code. So I go into the, I go to my command line, and I run npm install foo. And what npm does is it adds it to my package.json locally, and in the node modules of my project, it puts the code of foo. But what if foo actually needs buzz? OK, no problem. npm will do the same thing. Under foo, it will create a node modules folder, and it will install buzz. And what if buzz needs bugs? Same thing. It will install it, and so on. What will happen, and now let's look at a slightly different scenario, very similar. Let's say that I want foo that installs buzz. In this case, in my node module, I will install buzz. But then I have a bar, and bar also requires buzz. NPM was simple at the days, and what it did is actually created another node modules and created buzz. So you would get any package that is needed just where you required it. And that was good, almost. This is a slide that was very popular in the last decade. I guess most of you have seen it. And if this is new, then you should know, and you're a Node developer, then you should have seen it. And NPM became popular, and you were installing more and more packages. And then they would say that Node modules is the heaviest object in the universe. And it was true. You could install just lots and lots and lots of files. So size was the first problem. Another one, which is more common, by the way, than we think, is circular dependencies. So you have foo installing bar, installing buzz, installing bugs, but then bugs needs bar, so it installs bar and buzz and bugs, and then bugs needs bar and install that, and so on. So this was another problem with our method of installing node modules. This is for all people. Back in the day, Windows had a strange limitation. It's not the 640K of memory, but actually path names. Windows path names were limited to 256 characters, God forbid. And one of the problems when you start to install that, and it's getting deeper and deeper and deeper, is that it actually exceeds that. And this was a real issue if you wanted to remove or delete, and very painful one. So that's long path names. And the last one is a tricky one, which you still see to some extent today. What if you needed a package to appear only once? You needed it as a singleton. A typical example for that is, by the way, debug, which you need to instantiate, the debug package, which you need to instantiate only once. With the way that NPM installed the modules, you would get multiple instances, and then it will throw undefined, whatever. How can we solve that? So that was the idea of solving this issue. We will do something that is called deduping. In Israeli version, it's deduping. What you could actually do, if you have foods that require buzz and bar and bugs that require buzz, you can actually move both of them to the top level folder, which is at the same level of both of them. And the reason this works is the way Node is actually searching for modules. So if you start with bugs and you need buzz, Node will go to the adjacent node modules and look for it. It will not find it there, it will go one level up. It will not find it there, it will go one level up. And yes, that's where it is, and Node is fine with that. That's the search algorithm of Node. But then they went one step further. Why would we just dedupe all the duplicate packages where what we can actually do is move everything to the top level? The search algorithm will do the same, and we will have a shorter name, and we will have much less modules. And that's actually solved. It solved the problem. It is much smaller. We only have everything once, no problem. It is shorter path because you don't need to go 200 levels deep. It is unidirectional. The circular issue is gone because you only install something once at the top level. And it is unique because you only install one at the top level. Life cannot be any better, huh? Well, here is a pistol, versioning. And this is, if we have this scenario, where our project has foo requires buzz at some minor version after 1, and bar requires buzz at some version after 1.1, and we are already on 1.3, no issue. We can install it, we can flatten it to the top level, everything is fine. But what do we do here? What if foo needs buzz at 1, but bar needs buzz at 2? And the answer is that it depends according to the order that you installed. So if you installed foo before buzz, buzz will be installed at the top level, and buzz 1 will be installed at the top level, and buzz 2 will remain under bar. If you installed it in the reverse order, then you will get the buzz 2 at the top level and the buzz 1 under foo. And this is a problem because it's unpredictable. We don't really know what will be the outcome of our npm install. In fact, what is impacting the level of our npm install is 3 different forces. The first one is the one we can control, which is our package.json. What exactly and what version we put in the package.json. The second one, which is out of our control, is the npm registry. Did someone publish a new version to it? We don't know. We cannot control it. And the third one, which we can control, but only on our machine, is the current structure of our project. It depends on what we currently have, and this will define the result. So the solution that npm came was to snapshot. At least if you want to install a module and make sure that your colleague is getting the same structure, we can snapshot it. Initially, it was called shrink-wrap, or our CI in this matter, if you wanted to run on the CI without getting all kind of weird packages all of a sudden because someone updated the npm registry last night. And here we get to another problem, and it is the fact that in npm, when you write npm install, you in fact do 2 different things, 2 different intentions. The first one is install whatever currently exists in the package.json, but it also uses the exact same command in order to add new packages. So whenever you do npm install, npm will start recalculating the tree and trying to build a new tree. And this is where in 2016, Facebook got really upset. npm was unpredictable, unstable, and very, very slow. And they came up with their own package manager called Yarn. And Yarn is working quite similar, but it had three differences. The first one is the log file. Unlike NPM, that at the time the log file was optional, the shrink wrap file, in Yarn, it was the default. When you install, you get a log file, and you can commit this log file, and everyone else can get it. They separated the install of setting up, which is actually the Yarn command, of building the current tree from the log file, and add, which is a totally different command. And they made it a lot faster. And this brought actually the package managers arm race, or the war of the package managers, which in NPM, when they moved from version 4 to version 5, they made it a lot faster. They introduced the log file and so on. This is roughly where we are today. With NPM, there are new versions that did a different calculation. But let me tell you about some quirks that we can still see today. And most of you, if you have a large package JSON, you might have encountered. So the first one is, let's say you wanted foo, and foo needed buzz 100. So you installed it. It was flattened. So now you get 105. If you then add a bar that required 105, NPM will actually go and update, because the 1.06 is actually compatible with all the buzzes that you need. So you will get a new 1.06, or maybe there's already a 1.07. But if you have a 1.00 on foo, and it was installed at the time at 1.05, but bar doesn't require a new version. You require the 1.00. Up until NPM 6, it will not go and refresh. So you will get the good old version that you have. So this is why you have so many answers on Stack Overflow that's suggesting you that if you have some problems and you need newer version, this is what you need to do. RM, RF node modules, RM package lock JSON, and run npm install again. Another problem is that you actually don't have any control apart from the top level of your package JSON. So if you have a foo that is not that often updated, or maybe it's updated too often, and your other packages are not, or this is an example where your project has buzz 4, maybe you required it, but your foo and bar need different versions. In NPM, this is not really solved. It is, however, solved in Yarn. Yarn has a resolution section that you can add to package.json, and there you can specify lower level version. So you can say, the buzz under foo, I want 3.1, or I actually want version 4 or any other version, or you can go as deep as you want in the tree. Any bar under foo, put it under this version. So now with Yarn, you have much better control over lower levels. Okay, good. So this problem, in fact, occurs because there's an inherent difference. Our folder structure is a tree structure. Each folder is actually one parent. Our package graph, in fact, our packages is actually built as a graph. So each package can point to any level, to any other package with any other versions. And recently, newer package managers are trying to solve it, and let's see how. So PNPM is actually taking the problem in another level. And what it does is actually, it is building the tree in the very naive structure that we have seen. So if you have any version you have under each folder, it creates it. But it doesn't install the packages themselves. All the packages with all the versions, he put them in a cache. in a nearby cache with all the versions. And then at the operating system levels, it is mapping with hard links from the folder that Node will look into to the actual place where the package is being stored. And this actually can solve some of the issues. It can solve the size, for instance. It can solve other than circular. And this is at a very high level the way PNPM work. Another solution is coming from Yarn version 2. Its code name is Barak, and it's plug-and-play mechanism. And Yarn is actually saying something basic. Node doesn't really know about packages. Node understands folders. The tool that should know about packages is actually the package manager. Well, it has package and manager is its name, so it's likely that it needs to know about it. So we are going to store in Yarn, in a local cache, all the packages and all the relationship between them because we already know it. And whenever Node does a require and try to get a package, we will stand in the middle. It's actually patching Node. And we will get him the right version and all the packages that it actually needs. So what Yarn is doing is, in fact, changing the way Node is doing the require. Good. That's basically it. It's amazing to see how Node has grown in these years. You just see Node is now, NPM has grown. NPM is now being, it is also some of the ideas are also used in the Rust and Go package managers. And while I was researching for this talk, I actually stumbled on a really nice piece that Isaac Schluter, the creator of NPM, has written back in 2011. And it's amazing to see how he, I would say, predicted the future back then. So let's hear.
This thing was a baby yet. But these kids grow up before you know it. Pretty soon, you'll all be tapping out your pipe on the front porch, saying in your withered old man voice, I remember back before the war with the machines, when that NPM thing couldn't even install itself, and didn't know what a version was. We used promises for everything, and the global object was called Node. Movies were a nickel, and we downloaded them from the microtorrents, and soda pop had the corn syrup of the highest fructose imaginable. You young'uns don't know how good you got it.
That's it for me. Thank you very much. I would like to give a special thanks to our keynote speaker, Gil Tayar, who helped me on this one. Thank you, Gil. Thank you all, guys. It was great.